Okay, number 31 says, given the recursive formula for a geometric sequence, find the explicit formula of the first 5 terms and the term named in the problem. So I know that in an explicit formula, I've got, oh, interesting. Um, guys, I didn't realize that I'd done this, but you can have it and explain it, or you can have it write it in different ways. Do you see that this recursive formula is slightly different from how we do the recursive formula? So all this means is a term and the term after it, n plus 1 is after it. So in ours, let's go ahead and leave it as a sub n and a sub n minus 1. So it's the same thing, but just different way of writing a term and then the next term. Okay? Anyway, so, okay. The first term is negative 2. I want the first 5 terms, so 1, 2, 3, 4, 5. So I know that the common ratio is the part in the explicit formula right here, so times 2, so I multiply my 2, so that means negative 4, negative 8, negative 16, and negative 32. So very similar to the last problem. And I need the explicit formula. A sub n equals a sub 1, which is negative 2, times the common ratio 2 raised to the n minus 1. And that's my explicit formula. Those are the first 5 terms. And then the last thing I need is the term named in the problem. So a sub 11 equals negative 2 times 2 to the 11 minus 1, so 10. So basically, 2 to the 11th times the negative. 2 to the 11th is 2048. So negative 2048. Okay. On number 32. Again, we're going to think of this as a sub n and a sub n minus 1. Same difference. The common ratio is what goes right here, and then the first term is right there. So the first 5 terms are 4, and then I'm multiplying by 3. So times by 3 is 12, times by 3 is 36, times by 3 is 108, times by 3 is 324, I think. So now I need the explicit formula. So a sub n equals a sub 1, which is 4, times the common ratio 3 to the n minus 1. And then the last thing I need is the 10th term. So a sub 10 equals 4 times 3 to the 10 minus 1, so 9. 4 times 3 to the 9th. 4 times 3 raised to the 9th is 78,732. And that is the 10th term. Okay. So that's all given information, given like explicit information, find the different formulas and the terms. Now, here's where I start giving you pieces of terms from the sequence, and then I ask you to tell me what you know about, or to write the formula for the sequence from that. So, here's what I know. I know the first term is 1. I've got the second, the third, and then the fourth term is 64. I want to find the 10th term. I want to find the common ratio and the explicit formula. So, if I use the formula a sub n equals a sub 1 times r to the n minus 1, what I do know is that the first term is 1. I don't know what the common ratio is, but I do know that if I let a sub n be a sub 4, which is 64, so if I let this be 64, then we're talking a sub 4, so that is a 4, so I'm raising it to the 3rd power, yeah? So if I want to solve for 64, divide by, well, you don't need to divide by 1, but 64 equals r cubed. If I want to solve for r, then I take the cubed root. And I know that the cubed root of 64 is 4. So r equals 4. And that's one of my answers because it asks for the common ratio. Now it also asks me to determine the explicit formula. So a sub n equals a sub 1, which you already know is 1, times the common ratio of 4 to the n minus 1. And that is the explicit formula. Now as far as finding the 10th term, then I can just say a sub 10 equals 1 times 4 to the 9th. And 4 to the 9th is 262,144. Okay? If you want to check yourself, you can by multiplying by 4, and I get 4 times by 4, and I get 16 times by 4, and I do get 64, so we are correct. It's a good idea to check yourself. All right, on number 34, I give you the third and the fourth term. So 1, 2, 3, 4. So the third term is 27, and the fourth term is 81. So if I want to find the common ratio, all I got to do is divide any term by its previous term. 81 divided by 27, and I get 3. So that means my common ratio is 3. If I want to find the explicit formula, I need the first term. So I know that a sub n equals a sub 1 times r to the n minus 1. So it doesn't really matter which one you use here. I'm going to go ahead and use the third term. 27 equals, I don't know, times the common ratio to the, well, it's a sub 3. Yeah? So that's 3 minus 1, that's 2. Okay? So then that's 9. If I divide by 9, I get 3 equals a sub 1. Now, I could work it a different way, though. If I multiply by 3 going this way, then what I could do is just divide by 3 going that way. 27 divided by 3 is 9. 9 divided by 3 is 3. So going backwards, you divide by 3 instead of multiplying by 3. But you can also just use the formula to solve for a sub 1. And then I need the explicit formula. A sub n equals a sub 1, which is 3, times the common ratio, which is 3, to the n minus 1. And if I want to find the 11th term, then that is 3 times 3 to the 11 minus 1, 10, which is really just 3 to the 11th, because 3 times 3 to the 10th, and 3 to the 11th power is 177,147. Make sure you're following along on process, too. Okay. 35 is a little bit different because I don't give you 2 terms beside each other, and I don't give you the first term. I give you the fourth and the 7th. So here's what I know. I know that 1, 2, 3, 4, 5, 6, 7. Okay. Should have given myself more space for these. So I know that 1, 2, 3, the fourth term is 156.25, and the 7th term is 2441.40625. Okay. What I can do is pretend like this is the first, second, third, fourth term, and use that to solve for my common ratio. And once I know my common ratio, then I can use that to solve for my first term. So here's what I'm going to do. I know that a sub n equals a sub 1 times r to the n minus 1. So if I let this be a sub 4, then we're pretending like it's this. So 2441.40625 equals a sub 1, which we're pretending to be 156.25, times the common ratio, which I don't know, to the, a sub 4, so 4 minus 1 to the third. So what we're doing is just pretending like this is the first term and that's the fourth term, and just doing exactly like how we did 33. Now, if I want to solve for this, then I'm going to divide by 156.25, and then take the cubed root. So the cubed root cubed root is under math if you want to just go straight to a cubed root of something, or you can just say all of this raised to the 1/3 power. So 2441.40625 divided by 156.25 raised to the 1/3 power, and I'm left with 2.5. So I know that my common ratio is 2.5. Now, That means going in this direction, I multiply by 2.5. And if I want to check that right quick, I'm going to go ahead and do that. 156.25 times 2.5 times 2.5 times 2.5, and that's what I get. So that would have been this term, the 5th, the 6th, and the 7th. And I get exactly what I'm supposed to. That means I could work backwards and say 156.25 divided by 2.5 divided by 2.5 divided by 2.5, but I'm just going to work it out as a sub n. I'm going to let this be the 4th now. So 156.25 equals, I don't know, a sub 1 times the common ratio 2.5 to the, if this is 4, to the 4 minus 1, the 4th term. So basically I'm going to take 156.25 and divide it by 2.5 raised to the 3rd. And I'm left with 10. So a sub 1 equals 10. It does say given, find the common ratio, which we did. The term named in the problem and the explicit formula. So the explicit formula is a sub n equals a sub 1, which is 10, times r, which is 2.5 to the n minus 1. And the term, if I want to find, oh, the 5th. So that's easy. I already know the 5th. It's 156.25 times 2.5. And it's 390.625. So the 5th term is 390.625. Okay. Last one of the sequences. Okay, I've got the 1, 2, 3, 2, 9, 1, 6, 4, 5, 6, 7, 8, 9, 256. And I want to find the first term, the common ratio, the explicit formula, and the term named in the problem, which is the 6th term. So here's what I know. Again, I'm going to pretend like this is the first term, and that means this is the 1, 2, 3, 4, 5, 6, 7, the 7th term. So I'm pretending I have the, I don't know why I tilted so much, sorry. I'm pretending I have the 1st and the 7th term. So I know that a sub 7, or a sub n, right? A sub 7, I don't know, I'm doing this 3 times, which is 256, equals a sub 1, which we're pretending to be this one, 2916, times the common ratio, which I don't know, to the n minus 1. So remember, a sub n, which is a sub 7, this is 7 minus 1. Pretending like it's the 7th term. So I need to basically divide by 2916, and then take the, that's a 6, so take the 6th root, or raise to the 1/6 power. So 256 divided by 2916 raised to the 1/6 power. And that is 0.6 repeating, which is 2/3. So my common ratio is 2/3. Now, I want to find the first term now. So it really doesn't matter which term you use. I'm going to go ahead and use the, well, no, I'll go ahead and use the 3rd to make it easy. I know a sub n, which is, we're going to let this be a sub 3. So 2916 equals a sub 1, which I don't know, times the common ratio, which I do know, 2/3, raised to the n minus 1, so 3 minus 1. So basically I need to take 2916 and divide it by 2/3 to the 2nd power. And I get 6561 is my first term. Now, like I said, you can always work it backwards. If we multiply by 2/3 going this way, then that's like dividing by 2/3 going that way. So let's see if that makes sense to you. 2916 divided by 2/3, or multiplied by 3/2, 2916 times the reciprocal, 3/2, and you get, oop, not 3/5. And you get the same thing. So if I take that answer and I also divide it by 2/3, then I get the initial number, which we just found is 6561. So you don't have to work out this formula to find the first. You can just work it backwards. Instead of multiplying by 2/3, divide by 2/3, and you get the first term. And I need that to find the explicit formula. A sub n equals a sub 1, 6561 times the common ratio, 2/3 to the n minus 1. Not n plus 1, n minus 1. Yep. And then the last thing it asked me to find is the sixth term. So a sub 6 equals 6561 times 2/3 to the 6 minus 1 to the 5th. So 6561 times 2/3 to the 5th power, and that leaves me with 864. Or I could have just multiplied by 2/3 twice. Alright, composition of functions. So this first part is actually just using with the numbers. So when it says find f of g of 3, so I'm supposed to find the inside function first. So I'm supposed to find g of 3. So I go here and I say g of 3 is 3 squared plus 2. That is 9 plus 2, that is 11. So I'm really trying to find f at 11. So if I plug in 11 right there, I've got negative 2 times 11, which is negative 22, minus 5 is negative 27. So that one is negative 27. Now on 38, I need to find h of f of negative 5, so I need to find f of negative 5 first. So when I plug in negative 5 into f, I've got negative 2 times negative 5, that is a positive 10, minus 5, and that is 5. So I need to find h of 5. H of 5 is the square root of 5 minus 4, which is 1, so that is 1. Number 39 is k of h of negative 12. So first I want to find h of negative 12. So h of negative 12 means I plug in negative 12 right here. Negative 12 minus 4 is negative 16. The square root of negative 16 is 4i. And then I want to find k of 4i. So that means I'm going to plug in 4i in for k, or for x into k. So I've got negative 3 times 4i squared minus 4 times 4i, and then plus 10. So I end up with 4i squared is 16i squared, which is a negative 16, so that's a positive 48, minus 16i plus 10, so that is 58 minus 16i. On this one, this is actually g of 3. So I need to find g of 3 first. So 3 squared is, well, we already found that, it's 11. So then I need to find g at 11. So 11 squared is 121, plus 2 is 123. And so there you go. F of h of 29. So h of 29, so the first thing is h of 29. 29 minus 4 is 25, and the square root of 25 is 5, so I'm really finding f of h of 5. So h of 5 is 5 minus 4 is 1, so it's 1. So now I'm really just trying to find f at 1, and that is a negative 7. Last one, h of 8. So I'm going to plug in 8 right there. I got the square root of 4, which is 2. And then I need to find f at 2. F at 2 is negative 4 minus 5. That's a negative 9. I need to find g of negative 9. So that is a negative 80, or sorry, a negative 9 squared is a positive 81 plus 2 is 83. So I need to find f at 83. So negative 2 times 83 is negative 166 minus 5 is negative 171. Is that what you guys got? Did y'all do the composition yet? Okay, did y'all get that? Because I just did it in my head. Okay, I'll fix it if it's wrong.